Hello friend, let's start with the uses of dimension. This is the part 2 of video of this chapter. Let's start. The theory of dimension have the following main uses. The first is conversion of unit. This is based on the fact that the product of the numerical value and its corresponding unit u is always a constant, that is n into u is constant. I'll just give you example. N may be any value like 3, but use its SI unit like the corresponding unit. It may be kilometer, kg, and n is the specific value. According to this, n1 u1 that will be equal to n2 u2. Let's suppose the dimension of a physical quantity are a in mass, b in length, and c in time. If the fundamental unit of one system are m1, l1 and t1, and in the other system if it is m2, l2 and t2, then we can write this as a n1, m1 raised to power a, l1 raised to power b, and t1 raised to power c, that is equal to n2 into n2 is nothing but the numerical value, m2 raised to power a, l2 raised to power b, t2 raised to power c. Here n1 and n2 are the numerical value in two systems of the unit respectively. Let's say using this equation we'll solve the problem. You'll get better idea if I use the example. I'll just show you the example. Let's consider one example here. Okay. So there is the example. The value of the gravitational constant is G equal to 6.67 10 raised to power minus 11 Newton meter square kg square. As you can see that value of G is given, which is 6.67 into 10 raised to power minus 11, which is a fixed value in terms of meter and kg. It's an SI unit. Now the question is convert it into CGS system of unit, which is very important part of this problem. You will find many problems based on this conversion. Let's start with the conversion. Let's see the example. Guys, I have already discussed about the gravitational constant. The dimension is m inverse l raised to power 3 t raised to power minus 2. If you have not got this, then just refer the previous video. Okay, let's multiply the numerical value n1, which is nothing but the 6.67 into 10 raised to power minus 11, and here is the n2, which we need to find. The n2, the value which we need to find in terms of CGS, but the dimension will remain same, m1 l raised to power 3 t raised to power minus 2. So if we need to find n2, then this whole term m2 l raised to power 3 t2 raised to power minus 2, all this term will come in denominator. And now the next step we will do is we'll just take m1 and m2 raised to power minus 1. Since the power is same, we are keeping m1 m2 raised to power minus 1. On the other half, L1 by L2 raised to power 3 is there. As you can see, 3 is there. So just skip this 3. And the next part is time, which is T1 by T2 is raised to power minus 2. Let's put the value of N1, which is given in this problem, 6.67 to 10 raised to power minus 11. Okay. So if we consider when the numerical value was 6.67, I mean like n1, at that time m1 will be in kg and length will be in meter. So m1 will be in kg and l1 will be in meter, but the time will remain in second, because for SI unit we use mks, meter, kg and second, and for CGS length will be in centimeter, mass will be in gram, and time will be in second again. So if you divide this value, let's put the value in place of m1. The m1 will remain in kg, 1 kg, but m2 in place of this m2. Now the m2 is nothing but 1 gram, and this 1 gram can be written as 10 raised to power minus 3 kg. This L1 will be 1 meter only, so just place the value 1 meter here, and L2, this L2 is nothing but 1 centimeter, and this 1 centimeter can be written as 1 by 100, that is nothing but 10 raised to power minus 2 meter. t1 by t2 is nothing but 1 by 1 second 1 second. At last, solving this, we'll get n2 as a 6.6 into 10 to the power minus 8. Thus the value of g in CGS system of the unit is 6.67 into 10 to the power minus 8 9 centimeter square j square. So this will be the problem. Such type of problem we will ask in examination. Okay. Let's talk about some other uses. Next uses is to check the dimension correctness of a given physical equation. Well, every physical equation should be dimensionally balanced. This is called principle of homogeneity. The dimension of each term on both the side of equation must be same. On the basis, we can judge whether a given equation is correct or not. But a dimensionally correct equation may or may not be physically correct. Let's see. So that the correction of the time period t is 2 pi root L by G. So here we need to prove LHS is equal to RHS. So in LHS this is time period. So we know that the dimension of the time period is t only. So in LHS there it is the t, this part t. Okay, 2 pi is there, so we don't have the dimension for the constant. Just ignore this. Keep this square root as it is. So here is the square root part. So length will be having the capital A dimension, and g is nothing but the acceleration due to gravity. So as we know that the dimension of acceleration is nothing but L t raised to power minus 2, which is nothing but meter per second square. Okay, so let's see, this L and L will get cancelled. This t raised to power minus 2 will become t raised to power 2. The square root of t raised to power 2 will give you 2. As in the given equation, we find LHS is equal to RHS. Hence, we can state that this is dimensionally correct. This equation is dimensionally correct. So this was the uses of dimension. Let's see the principle of homogeneity dimension. This principle states that the dimension of all the terms in a physical expression should be same. For example, in the physical expression like s is equal to ut plus half at square, the dimension of s, which is given here as displacement distance, ut nothing but again formula of distance, u velocity into time, half at square, all must have the same dimension. Then it can be add or subtract. So whenever you get addition or subtraction, you must have get an idea that all have the same dimension. I just give you example. Let's consider you can add you need to add 2 mango with 3 mango. Then it will be quite easy for you. Just add the mango, 2 mango with 3 mango, you will get 5 mango. But you can't add mango with apple. Same way, there while addition the dimension must be same. Let's see the one problem. The velocity v of a particle depends upon the time t. According to the equation that is given, v is equal to, v is the velocity here, a plus bt plus c upon d plus t. Dear friend, here v is the velocity and a, b, c, d is nothing but the constant. We need to find the dimension of the a, b, c, d, which are the constant given value. We need to find the dimension of this value. So not a constant, sorry. Let's use the principle of homogeneity. According to this, v will be equal to a, v will be equal to bt, and v will be equal to this whole term. Okay, so let's equate v with a. So with v with a, it means a will have the dimension is nothing but the equal to the velocity, and velocity having the dimension Lt inverse. So we got the value dimension of a. Let's now equate this velocity with bt. So bt, so b, this keep this b as it is. What about the t? T will have the capital T, and v is the velocity, again Lt inverse. So this t, this part t, denominator part t will come numerator, and this will become Lt raised to power minus 2. So finally we will get b as a Lt raised to power minus 2 as a dimension. Let's talk about the other two remaining part, which is c and d. Dear friend, let's see, d plus t is there. So in the part d and t is adding. So as I said you that the addition must be done on the same phase. So it means dimension of d must be equal to time. So that is the reason these two terms are getting added. So you can just directly add d with d is nothing but the dimension of t. So dimension of d is nothing but the capital T. Now the last part, v is equal to c upon d plus t. Okay, so d plus t will have nothing but the dimension as a t only. Okay, because at last you add or whatever, you can't write, the dimension will remain same. Either you just write 2t or t. We just have to keep t only. We are looking for the dimension. We are not looking for the numerical value. 2t doesn't matter. We are looking for the t only. So at c, this velocity into t will get multiplied here, and we'll get velocity, this velocity I'll take inverse, and instead of d plus t, it will be t only, because the dimension is 4. D or t is nothing but t only. Don't confuse. You don't need to write the 2t. It may happen some of the student will get write d plus t, so t plus t 2t, so it's wrong. Okay, so you need to just skip the dimension only. So at last we'll get c as L. Now let's see establish the relation among the various physical quantities. If we know the factor on which a given physical quantity may depend, we can find a formula relating to the quantity with those factors. Let us make an example. The frequency of a stretched string depends upon the tension. Let's say the tension is represented by F, dimension of force, length of the string, and one more part it is given in the question, that is mass per unit length, which is mu here, as you can see in the slide here, mass per unit length. Derive the formula. So dear friend, whenever such type of problem will be there, what you need to do, just suppose that the frequency F depends upon the tension raised to power A. One thing is given in the question, that the frequency is directly proportional to the tension, which is force here, but we don't know the raised to power. So let's assume it by x, y, z, or just assume it here as in this problem, I just assume it by A. So let's say F raised to power A. Then it also depends upon the L, as the question said. So F is directly proportional to L. And one more thing, which is mass per unit length. So finally the frequency depends upon these three quantity and raised to power A, B, C. As you know that if you need to remove this directly proportionality, we require a constant. So there is a constant value. At last we need to just put the value, like F is there, which is force. So we know that the dimension of the force is ml t raised to power minus 2, mass into acceleration. L will have the L only, length, and mu nothing but the mass per unit length. So mass upon length is nothing but L inverse raised to power C. We just keep the power as a ABC here, which is unknown value. Now we will equate the part. In mathematics we must have an idea how to equate the value. So we'll consider m at a time. So m raised to power A is there in the first part, L raised to power B is there, so we don't have m in the second part. There we have the third. In third we have m raised to power C. On equating we'll get m raised to power A plus C. Okay, what about the L? In the L we have L raised to power A, there we have L raised to power B, and there we have L raised to power minus 1 into C will give you minus C. So we'll get overall L raised to power A plus B minus C. Let's talk about the third part, which is T. So T raised to power minus 2A, then T raised to power, oh no, we don't have any other value, so just skip this 2 raised to power T raised to power minus 2A. Okay, got it. Now equate it with the left hand side, and left hand side there is m raised to power 0, L raised to power 0, and T raised to power minus 1. Why? Because frequency is nothing but the 1 upon time period, so 1 upon time period can be written as T raised to power minus 1. On equating we'll get A plus C. Here we have the value of m as a 0, just equate with this A plus C as equal to 0. Let's equate with the L now. A plus B minus C, that is equal to 0 again. And what about the T? Minus 2A, that is equal to minus 1. So we'll get A as a half. I hope this is clear to you. Minus minus will get cancelled. A as a 1 by 2. So let's put this 1 by 2 of value of A into the equation number 2 here. Let's see 2. So we must get an idea. We'll get the value of C. A is 1 by 2. So C will be minus 1 by 2. And at last, if you put the value of A, C in equation number 3 here, so we'll get the B as well. So B is nothing but minus 1. So finally we need to put all this value in the equation 1, that is F is directly proportional to K raised to power FA, B, F raised to power A, L raised to power B, and U raised to power C. Okay, so let's see here the last part. We need to just put the values. K is as it is, F raised to power half, L raised to power minus 1, mu raised to power minus half. So as you know that it is F raised to power half and mu raised to power minus half. So this is nothing but F raised to power half can be square root of F. Minus half is there, so it will be in denominator root of half. So this combining can be written as F by mu, and L inverse is 1 upon L. So at last we'll get this as a relation. So experimentally they find that this is nothing but, the k is nothing but 1 by 2. So this is not come in the examination. You need to solve till here only. Even if you have any doubt, just comment me. Please comment me on the, there is a comment box on the video below. Just ask me your doubt, and definitely I'll try to resolve it as soon as possible. Okay, let's see the limitation of the dimension analysis. This method of dimension has the following limitation. By this method, the value of dimensionless constant cannot be calculated. By this method, the equation containing trigonometrical, exponential and the logarithmic terms cannot be analyzed. If a physical quantity depends on more than 3 factors, then the relation among them cannot be stabilized, because we can find 3 equations by equating the power MLT. Let's talk about the significant figure now. Very important topic which we are going to cover right now. The significant figure in the measure value of the physical quantity tells the number of digits in which we have the confidence. Larger the number of significant figure obtained in a measurement, greater is the accuracy of the measurement. All accurate known digit in a measurement plus the certain uncertain digit together form significant figure. Let's see how it will come in the examination. Here we have the problem. Well, so significant figure depends on the least count measuring instrument. For example, if we measure the length of the straight line using a meter scale and it lies between 7.4 to 7.5, so we may estimate it as 7.43. This expression has 3 significant figures. Out of this, 7, 4 and precisely known, but the last digit 3 is only the approximately known. Let's talk about the rules for counting the significant figure. Very important rules are there. All non-zero digits are significant. So whenever non-zeros are there, like 2, 5, 6, 7, we need to consider this as a significant figure. The zeros appearing between 2 non-zeros are counted as a significant figure. Let's say even if it is decimal is there, like 6.028, so we'll consider this as a significant figure. So the overall value will be 146, 140, 142, 148. So it will be overall 4 significant figures there. If the number is less than 1 on the right of decimal point, but on the left of the first non-digit are non-significant. What I'm trying to explain, let's the number is less than 1, so it's a 0.0042 is there, which is less than 1 value. So the right of the decimal point but to the left of the first non-zero are non-significant, means before this 4 all the 0 will be non-significant. So here the significant figure will be 4 to only. Like see one more example, for 0.032, so we will not consider 0 at this point because 3 is coming as a non-significant figure, so we'll consider 3 2 as a significant digit only. So the value will be 3 and 2 value will be there. Let's talk about the 4th rule. The terminal or trailing zeros in number without a decimal point are non-significant. Thus 4 to 6 meter or 4 to 600 centimeter or 4 to 600 millimeter has 3 significant figure. So whenever at right you will get 0 0 0, so you don't need to consider the value. Rule 5. In a number with a decimal, 0 to the right of last non-digit are significant. For example, if it is 4.600 or 0.002300 have 4 significant figure in each. Okay, just try to understand. If a number with decimal, earlier it was not a decimal. If you consider the rule number 4, it was not a decimal. Okay, so we don't need to consider 0, but if it is decimal is there in a number with the decimal, because we have to be very accurate, so whenever it is decimal is there, so we will consider the value of 0 as well. So in both the cases it will be 4 significant figure. In this, as this 0 is on the left side, we will not consider this 0, but on the right side we will consider this 0 as a significant figure. Okay, so point of confusion it may happen, like suppose we change the units, then we will write 2.00 meter, or either you can write 23.0 centimeter. or either you can write 2300 millimeter, or either like 0.00230 kilometer. So in all this case, you will find the significant figure will remain same. Got it? So let's say rule 6, the power of 10 is irrelevant to the determination of significant figure. For example, in the measurement 2.30 meter, 2.30 into 10 to the power 2 centimeter you can write, or just write 2.30 into 10 to the power 3 millimeter, or just write 2.3 into 10 to the power minus 3 kilometer. The significant figure are 3 in each measurement because all 0 appearing in the base. All 0 is appearing in the base here, 10 raised to power, right? So are significant. Well, let's see the rule 7, which is the last rule for this. A choice of change of different units does not change the number of significant digit or figure in a measurement. For example, the length is 7.03 centimeter, has 3 significant figures, but in the different unit, the same value can be written as 0.0703 meter or 70.3 millimeter. All these measurements have the same number of significant figures. As you can see, there is a 7.03 centimeter. So as I said you in the earlier rule, you can refer this. There will be 3 significant figure. Even in this 0.0703 will have the 3 significant figure, and 70.3 millimeter is there. Even if it is there, this 3 significant figure. That is all about the rule of significant figure. Let's talk about the rounding of digit. We have only 2 rules there. If the number lying to the right cutoff digit is less than 5, then the cutoff digit is retained as such. However, if it is more than 5, then cutoff digit is increased by 5. Let's say you will get better idea by example. If it is 6.24, the next digit, which is 4, which is less than 4, so the previous one, which is 0.2, will retained here, so it will be remain 6.2. But in case if it is 5.328, so after 2 there is a 8 which is greater than 5, so this 2, previous one 2, will be increases by 1 value, so the value will be now 5.33. This is the rule. Okay, got it. Let's see rule 2. If this insignificant digit to be dropped is 5, so earlier it was the rule was either it will be greater than 5 or less than 5, but in this situation if it is the drop to at exactly 5, then there will be 2 cases in this. So the preceding digit is even, then the insignificant digit is simply dropped. If the preceding digit is odd, then the preceding digit is raised by 1. Let's see with the example. It's 6.265, so 5 is at the end, so let's see the preceding one. Preceding one is 6 here, which is an even number, so rounding off, the answer will give you 6.26 only. But in case if it is an odd number like 6.275, so preceding one of the 5, which is 7 here, rounded off will give you 6.28. We need to just increment this 7 value to 1, will get 6.28. Got it? Let's get a better idea with the algebraic operation with significant. In addition and subtraction, multiplication or division, the final result should not have more significant figure than the original data for which it was obtained. Let's get a better idea with the example. Well, here is the example. Let's see if it's 1.2, 3.45 and 6.789. So actually, while addition you will get 11.439, but we have to consider the least number of significant digit. If we consider this, so 1.2, so 1 and 2 is the significant digit here. There is 3.45. In 3.45 we have 3 significant figure, and in 6.789 we have 4 significant figure. So we need to consider the least number of significant digit after the decimal is 1. Hence the result will be 11.4 only, because in this situation you find the least number of significant digit after the decimal is 1 only. Least is 1. In this situation after the decimal is 2. In this situation after the decimal is 3. So after the decimal is 1 only, so the answer will be 11.4 after the decimal 1 only. Got it? One more example like 12.63 minus 10.2. So you will find the least digit after the decimal is 1 only. So in the answer you will get 2.43. So at last we will get 2.4 only. Let's talk about the multiplication or division. Suppose in the value to be multiplied or divided, the least number of significant digit be n, then in the product or quotient, the number of significant digits should be n only. I repeat, if in the measure value to be multiplied or divided, the least number of significant digit is n, then in the product or quotient, the number of the significant digit should be n. Let's get better idea with the example 1.2 into 36.72. So we got the value which is 44.064, which is a overall value, but we have considered only 44. Why so? Because the least number of significant digit in the measurement values are 2. It is 1.2. Okay, the least number of significant digit in the measured value are 2. Hence the result, when round off of 2, significant become 44 only. Dear friend, don't be confused. Earlier we need to see in addition or subtraction, we need to check after the decimal point, but in this we need to consider the significant figure value only. Okay, let's see one more example for division. It's 1100 divided by 10.2 will give you 107.8431373. So if you see, the least number of significant figure is 10.2 and like 3. In numerator it is 4. So the answer will be up to 107. But how they have written this as a 110? Let's see how they have written this. So as 1100 has the minimum number of significant figure is 2 only. Dear friend, you must remember using a rule that if it is the right hand side rule 0 0 is there, so they will have the 2 significant figure, right? We have to ignore the remaining 0 which are on the right hand side, right? If decimal is not present over there, remember. So in this situation, 10.2 will have the 3 significant figure and 1100 will have the 2 significant figure. Hence we will just round off to be 107 will become now 110. As minimum number of significant figure as 2, therefore the result should also contain only 2 significant figure. Hence the result when rounded off will give you 110. How 110? You can see. Let's see. It's 11 divided by 10.2. We'll get 107.84. Rounded off will give us, since it is 0.8 is there, so we'll give you 108. But even if in this situation we have to consider up to 2 digit value, so if it is 2 digit value, we'll give you this one. In this case, answer becomes 108. Think why? Just have to give the answer in the comment box. Okay? Got it? The next topic will be error analysis. For this, we'll make another part of this video. Till then, thank you. If you like this video, please like. I really need your support, or just subscribe video for further information. Thanks a lot for watching this video.